We're going to look at one more example of calculating the sum, a finite sum of a geometric sequence. This one's a little bit more tricky, so I just want to draw your attention to that. We're asked to do two things. First is to calculate the finite sum, and then second, write the sum in sigma notation. So let's first calculate the finite sum. Well, this is clearly a geometric because to get to the next term, I'm multiplying by a common ratio. Looks like in this case it's 3. And so we have a formula for the sum of a finite geometric sequence, and that looks like this. S sub however many terms we're adding up is equal to my first term times 1 minus my r write it like this. S sub n equals a sub 1 times 1 minus r to the n divided by 1 minus r. Right? That's our formula. Now here's the thing we should notice. Do I know my first term? I do, so I can put that right in. Do I know my r value? I do, that's 3. So what do I not know? I don't know the n. In other words, I don't know how many terms I'm going to be adding up. I know what my last number is, but that's not what n is, right? What I'm trying to figure out in this problem is, or to figure out that n, I know that this is the first term, I know that's the second term, I know that's the third. The question is, what term is 8,748? So that information was purposely left out. So I have to go find what that is, and this is where we have to sort of take a little side trip to figure that out. So how would I figure that out? Well, I know that the term value is 8,748 of this geometric sequence, and since I know the explicit formula for a geometric sequence, what I can do is I can take my explicit formula, which is, in this case, 4 times my r, which is 3 to the n minus 1. And I know that the answer I'm supposed to get is 8,748. What I don't know is what number in the list that is. But I can solve this equation for n pretty painlessly. So what would I do first? I think I'd divide by 4. And when you divide by 4, you get 2187 is equal to 3 to the n minus 1. Now at this point, I could go through a really kind of a mathy way of finding out what n is. But the truth of the matter is, I know that my n has to be an integer. It's not going to be like 1.5, right? N represents the term number, so it's got to be an integer value. I think this is a perfect situation to use guess and check. So what I would do is I'd take out my calculator and I'd just start raising 3 to some powers. So let's see, 3 to the 5th equals 243, that's too small. 3 to the 8th is 6,561, that's too big. Let's try 3 to the 7th. 3 to the 7th works. So since 3 to the 7th equals that's what I just put into my calculator, that must mean that n minus 1 equals 7. In other words, n is equal to 8. So that was my little digression. Now I can take that and put it right in there. So what I basically just figured out was that this 8,748 turns out is the 8th number in this list. I didn't know that going in. So we plug that in and we finish the problem. So this is equal to 4 times 1 minus 3 to the 8th is equal to negative 6,560 divided by negative 2. And at the end of the day, this turns into 1,000 or 13,120. Okay, so that's a minor change from the previous problem. You'll notice in the previous problem they just told us n equals, and it was a matter of just plugging into the formula. Here we've got to do a little bit of work to figure out what the term number is of that 8,748. The last thing we have to do now is write this in sigma notation. So I'm just gonna. So if we want to write the sum in sigma notation, I'm going to get my sigma set up. Now, the rule of the sequence goes in here. So the rule is 4 times 3 to the n minus 1. That's easy. So we're adding up the terms as n goes from, well, the first term is a 4. And we're stopping at, well, what term is 8,748? That is the 8th term. Okay, so in sigma notation, what we just figured out was that this, we figured out what this equals. This equals 13,120. Okay, so that's that in sigma notation.